An undiscovered planet like Earth lies dormant in our solar system. What researchers have now found is truly incredible. In this video, we take a look at whether there really is an Earth-like planet beyond Neptune, and whether this solves the eternal mystery of Planet 9. And not only that, researchers have also discovered exoplanets in the depths of space that are strikingly similar to our Earth. Some may even be more suitable for life than our home planet. Be sure to stay tuned until the end, it's going to be really exciting. Welcome everyone. The search for a second Earth has preoccupied humanity for decades. Given the enormous number of exoplanets in our galaxy alone, the question arises as to whether Earth is really something special or whether there are countless Earth-like planets out there, and these new discoveries could finally provide us with the answer.
If exciting astronomical news like this fascinates you as much as it does me, then go ahead and subscribe to the channel right now. It doesn't cost anything. You won't miss any more videos and you'll help me out a lot. If you've already subscribed, giving this video a thumbs up helps it a lot. Let's try to hit 5,000 likes. Thank you so much, everyone.
Let's start with a discovery that could completely turn our solar system upside down. For years, astronomers have been puzzling over a mysterious ninth planet that is said to be hiding in the icy outer reaches of the solar system. And now there is a truly incredible suspicion: could Planet 9 be an icy version of Earth? And I don't know about you, but when I hear the term Planet 9, I always think of poor little Pluto, which was the ninth planet until 2006 when it was kicked out.
Don't get me wrong, there were good reasons for its demotion, because otherwise we would have had to classify numerous other celestial bodies as planets as well.
Like Eris, for example, which is about the same size as Pluto, but emotionally I remain a big Pluto fan. Let's take a vote. What do you think? Was it right to kick Pluto out of the planet club? Or do you say Pluto should be a planet again? Feel free to write your opinion in the comments. When people talk about Planet 9 these days, they mean a hypothetical additional planet in the outer reaches of the solar system that we have not yet discovered, but which many astronomers believe exists. How did they come up with that? The idea of its existence arose from the observation of inexplicable behavior of trans-Neptunian objects, or TNOs for short, which, as the name suggests, are located beyond Neptune. These TNOs, which include objects such as Sedna and the aforementioned Eris, exhibit super eccentric behavior. They form strange clusters, often have extremely inclined orbits, and we can see this perfectly in Sedna. And so the myth of Planet 9 was born. Of course, there is a little more science behind it than that. Computer models and simulations have been used to show that these observations can best be explained by the existence of a large as yet undiscovered planet. And until now, it was always assumed that Planet 9 or Planet X would most likely be a gas planet, perhaps comparable to Neptune.
And that would make sense too. Why shouldn't another gas giant have formed alongside the 4 gas planets we already know? Back then, when the solar system was still young and planets were clumping together from a primordial cloud of gas. But I can already hear some of you asking the perfectly reasonable question: if there were another gas giant out there, wouldn't we have found it by now, dude? You'd think so. But you shouldn't underestimate just how far away these regions of the solar system are. Even Uranus and Neptune were unknown to the people of antiquity and the Middle Ages, and were only discovered around 2 centuries ago with the advent of better technology. At this great distance, it is also very dark, and the light from the sun is so weak that a potential planet would reflect very little light and would therefore be very difficult to detect. Furthermore, Planet 9 would be a real slowpoke. At this distance, it would have such a long orbit around the sun that it could take years for it to move even slightly in the sky. By comparison, Neptune takes 165 Earth years to orbit the sun once. For Planet 9, we would be talking about at least 200 to 300 years, and this leisurely behavior would also make it tricky to distinguish it from the stars in the background. And now, there has been a truly sensational study in the astronomical community, with a team of researchers claiming that Planet 9 is not the expected giant gas planet at all, but actually an Earth-like planet, that is, a terrestrial rock planet, similar to our Earth, but also with some massive differences. According to their calculations, this secret world would have at least 1.5 times, but in no case more than 3 times, the mass of Earth, and would be no further than 500 astronomical units from the Sun. That would be incredibly far away. Neptune, for example, is on average only 30 astronomical units from the Sun, which is 4.5 billion kilometers. What a fascinating thought, isn't it? A kind of super-Earth with a solid surface in the dark reaches of the solar system. But now the not entirely irrelevant question arises: how on earth did they come up with that? Good question. In their study, the researchers write,
An Earth-like planet in a distant and inclined orbit can explain three fundamental characteristics of the distant Kuiper belt: a prominent population of TNOs with orbits beyond Neptune's gravitational influence, a significant population of objects with high inclinations, and the existence of some extremely peculiar objects with peculiar orbits. In other words, simulations and calculations have shown that the observed cluster formations and the inclinations of the TNOs can be better explained by an Earth-like planet near their orbit, and that makes sense to me, and I'll explain why. The fact that we have not yet discovered Planet 9 suggests either that it does not exist or that it is really far away. However, the strange behavior of the TNOs shows that there must be something there, so there is more to be said for the possibility that Planet 9 is really far away, but so far back in the solar system, there was probably never enough gas for a Neptune-sized gas planet to form. But what is abundant? There are asteroids and comets, and it is precisely from this material that a rocky planet could have formed quietly and secretly. And as the calculations from the new study show, which I have of course linked below in the video description as usual, would such an Earth-like planet, with this mass and at this distance, perfectly explain the behavior of the TNUs? Now, another question arises, but if it were that far away, wouldn't it just be a boring chunk of ice? Yes and no. It's definitely cold out there. But it is conceivable that there is cryovolcanism on Planet 9, as on the icy moons of Jupiter and Saturn. These moons are needed by the tidal forces of the massive gas planets, causing the ice to melt despite the cold temperatures and spurting out hot fountains on the surface. Depending on the geological activity on Planet 9, perhaps caused by impacts from Kuiper belt objects, this could also be conceivable there, or if this cold super-Earth had a sufficiently massive moon, this could also trigger cryovolcanism. I know it's speculation, but we have the realistic possibility that there is an Earth-like planet beyond Neptune that has an underground ocean, and who knows what forms of life might exist there. I've simulated what this planet might look like: an icy world with a hidden ocean beneath a thick ice crust, the sun visible only as a tiny dot in the sky. Now, of course, we need a galactic name for the new planet. Write me in the comments what you would call this icy rocky planet at the edge of the solar system. I'm super excited to hear your suggestions.
Amazing, isn't it? But there aren't just promising candidates in our own solar system. Because out there in the vastness of space, astronomers have already discovered several exoplanets that are strikingly similar to our Earth.
Kepler 22b, TRAPPIST-1e, and KOI 5715. These names may not sound very poetic, but behind them lie worlds that may be more hospitable to life than our own Earth. Researchers refer to them as superhabitable planets. Our first candidate for a second Earth is Kepler 22b. Astronomers are not yet entirely sure based on the data, but if the assumptions are correct, then we are dealing with an incredible world here, an ocean planet 2.4 times the size of Earth and tilted on its side like Uranus. Rocky planets of this size are also referred to as super-Earths, and so here we may have a super-Earth covered by an ocean that spans the entire planet. Kepler 22b is only 600 light-years away from us. Cosmically speaking, this is a mere stone's throw, and it is located in the habitable zone of its star system. If the planet has an atmosphere similar to Earth's, astronomers estimate the average surface temperature to be 22 degrees Celsius. NASA astronomer Natalie Battaglia says if it is mainly an ocean with a small rocky core, it is not beyond the realm of possibility that life could exist in such an ocean. However, life there would be truly extreme, because although Kepler 22b is only 2.4 times larger than Earth, it is probably almost 9 times more massive. Due to its extreme tilt, its north and south poles would be alternately bathed in sunlight and darkness for half a year as the planet orbits its star. Let's take a look at the next potential second Earth, which is only a mere 40 light-years away from us, TRAPPIST-1e. The TRAPPIST-1 system is one of the greatest astronomical discoveries ever, as it has 7 planets with solid surfaces more than our own solar system. And the planet TRAPPIST-1e lies in the habitable zone of this extraordinary system and is truly the best candidate for a second Earth in almost every respect. At 0.92 Earth radii, it is almost the same size as Earth, and at 0.96 Earth masses, only slightly lighter. To define how Earth-like exoplanets are, scientists have introduced the Earth Similarity Index, or ESI for short. A score of 1 on the ESI would mean that a planet is exactly like Earth. TRAPPIST-1e achieves an incredible 0.85, which means it is almost like Earth. The only slight problem is that all the planets in the TRAPPIST-1 system probably have a bound rotation, meaning that they always show the same side to their star. On TRAPPIST-1e, we would therefore have one side with eternal day and one with eternal night. The temperatures there would probably be much too hot or much too cold, But in the zone between the two, the temperatures could be perfect. This area is known as the Terminator Zone.
Hasta la vista, baby.
But not because of Arnold Schwarzenegger, but because Terminator is another term for the boundary between day and night. Imagine a ring-shaped area around the planet, exactly between eternal scorching day and eternal freezing night, where perfect Earth-like conditions prevail. And now, let's travel to a planet that some astronomers believe might even be better suited for life than Earth.
This planet has the easy-to-remember name KOI 5715. We'll now refer to it as KOI for simplicity's sake. As we already know, the decisive factors for a planet's suitability for life include the potential existence of liquid water, a stable atmosphere, and a suitable distance from the central star. KOI ticks all these boxes. It is just under 3,000 light-years away from us, orbits an orange dwarf star at the right distance, and has a diameter 1.8 to 2.4 times that of Earth. So what makes KOI superhabitable? That is better than Earth. The KOI star system is probably just under 5.5 billion years old, making it almost 1 billion years older than our solar system. This means that life has had more time to form. Evolution there, theoretically, has a 1 billion year head start, and that could make a huge difference. The orange dwarf star that KOI orbits is also more durable than the Sun, so life there would also have a longer future ahead of it. In addition, KOI's size makes it potentially super habitable. When searching for such worlds, astronomers look for precisely these planets, which are slightly larger and slightly more massive than Earth. This difference in size and mass could help the planet store more gases, energy, and heat. And if it could store more greenhouse gases in its more massive atmosphere, that would likely lead to much greater biodiversity. KOI could therefore potentially be a planet with more biomass and a much longer evolution than Earth, so we might find dense alien jungles here with life forms that have undergone a long and complex evolution. All these findings about these exoplanets are not yet set in stone, but in my opinion, the large number of candidates for a second Earth, or even a better Earth alone, shows that these planets are likely to be abundant in our galaxy.
From these promising candidates, we now move on to a discovery that is revolutionizing our search for extraterrestrial life.
Red dwarf stars have long been considered hopeless cases for the emergence of life. The reason? Violent bursts of radiation known as super flares, which regularly emanate from these stars and destroy any atmosphere. But researchers have discovered something incredible that changes everything. Since the first planet outside our solar system, known as an exoplanet, was discovered in 1992, we know that this is nothing special in itself. All over our Milky Way, planets orbit their stars, and there are lots of them. Researchers claim that there are at least 100 to 400 billion planets in our Milky Way, and probably many more, so there would be enough planets for extraterrestrial life. But what about stars? We know from our own experience that a star like the Sun seems to be quite suitable for the emergence of life. The Sun is a so-called yellow dwarf star, although dwarf is a bit misleading because the Sun is actually quite average in terms of size. Unfortunately, yellow dwarf stars are not particularly common in the Milky Way. A combination like ours, that is, a rocky planet orbiting a yellow dwarf star, is therefore not exactly the norm in the Milky Way. Instead, almost 75% of all stars in our galaxy are so-called red dwarfs. We can therefore conclude that the majority of exoplanets, that is, the majority of places where life could exist, probably orbit a red dwarf. The nature of stars can influence the probability of life. Until now, it was assumed that the fact that the majority of stars are red dwarfs was a bad sign for the search for aliens. This is because red dwarfs tend to be a bit explosive. They regularly eject gigantic energy storms into space. At the same time, red dwarfs are much cooler than our Sun, and that's why planets have to be very close to them in order to develop temperatures that are, from our perspective, suitable for life. And if you're very close to a star and it happens to fire off a violent stellar burp into space, that's rather suboptimal for the emergence of life. That's why, up until now, it was assumed that exoplanets orbiting a red dwarf are unlikely to host extraterrestrial life. And that means that 75% of all star systems in the Milky Way are basically ruled out in the search for life. Tough luck. But now everything is being turned upside down again by a new discovery about red dwarfs. The cosmos is just as paradoxical as before because red dwarfs spare their planets from their violent eruptions. Our Sun also regularly ejects bursts of energy into space, and in our Sun's case, this usually happens from the direction of its equatorial plane. For this reason, solar flares could theoretically also reach the planets, because they orbit the Sun at the level of its equator. A really violent solar storm could therefore theoretically be dangerous for Earth. But fortunately, we are at a safe distance, and our magnetic field protects us from the solar wind. To a small extent, the solar wind reaches us around the clock and is directed by the magnetic field to the north and south poles, where its energy causes the atmospheric layers to glow. However, things seem to be different for red dwarfs. The space telescope TESS, short for Transiting Exoplanet Survey Satellite, has been in near-Earth space since 2018, searching for exoplanets. To do this, it observes distant stars and waits to see if there is a decrease in brightness from time to time. When a star dims, it usually means that an exoplanet has passed in front of it. This method is called the transit method, and it has been used to discover nearly 80% of all exoplanets to date. While TESS waits for an exoplanet to pass in front of its star, it naturally has plenty of time to study the stars themselves. And thanks to data from TESS, it has now been discovered that the violent eruptions of red stars usually do not occur from the equatorial plane, but rather towards the poles of the star. Put simply, red dwarfs do not shoot their eruptions towards their planets, but rather upwards and downwards. This means that, contrary to previous thinking, stellar apocalypses are not the order of the day on red dwarf exoplanets. This is particularly good news for the habitability of our neighboring star system, Alpha Centauri. Alpha Centauri consists of 3 stars, one of which, Proxima Centauri, is a red dwarf. The exoplanet Proxima Centauri b, the closest exoplanet to us, orbits Proxima Centauri. It is basically the right distance from its star to have Earth-like temperatures, which means liquid water. The only point of doubt regarding the habitability of Proxima b in the past was that it was probably devastated by apocalyptic solar storms from its star, making the chances of aliens and a future human base rather slim. However, with the new findings about red dwarfs, we can now be optimistic again that life could exist on Proxima b.
At the end of our journey to the second Earths in the universe, perhaps the most fascinating discovery of all awaits us. In our cosmic neighborhood, astronomers have discovered a clone of our solar system. The Sun-like star is surrounded by planets like Jupiter and Saturn, and perhaps a second Earth is forming there as well.
Our solar system was really chaotic back then. The Sun formed about 5 billion years ago, and at that time, there were huge swirls of dust and gas that formed around this young star, and there was also a competitor to the Sun, namely Jupiter. But before we talk more about the rebellious youth of our solar system, let's first take a look at another star system with the beautiful name TY1089987601. Very creative, these astronomers. This star system is 300 light years away from us, but when you consider that the Milky Way is 100,000 light years across, that's really close. So this system, whose name I won't repeat, is in the immediate vicinity of our Sun, and it's the first other star system discovered in which a Sun-like star is orbited by 2 exoplanets. Unfortunately, the exoplanets orbiting the stars are not Earth-like planets, but gas giants like Jupiter and Saturn. The probability of life existing there is therefore almost zero, but what makes the whole thing incredibly interesting is that this solar system is a baby version of our own solar system because it is still very young. The star, which I'll call TY10, probably formed only 17 million years ago. In comparison, our Sun is 5 billion years old, so it's a real baby star. And that means we can learn a lot about what might have happened in our own solar system during its formation. And that brings us back to the turbulent early days of our solar system. I already mentioned that Jupiter was an adversary of the Sun back then, and Jupiter is also made up of lots of hydrogen, just like the Sun, only not quite as much. But in the beginning, it was a battle of the giants. If Jupiter had accumulated a little more hydrogen, the stellar fusion process might have been triggered in it, and Jupiter would have become a star. Then we might now have Jupiter at the center of the solar system, and the Sun would be the largest planet. That could have happened, but in any case, Jupiter's massive gravity ensured that enough rocks and boulders were swept into the inner region of the solar system, where the terrestrial planets could then form. So we may have Jupiter to thank for the formation of our Earth in the first place. And that's not all. Researchers even assume that Jupiter has repeatedly deflected dangerous asteroids from their orbits ever since, because when they approach Jupiter, its gravity changes their orbit around the Sun, or their path through the solar system, thus protecting the Earth from impacts. So perhaps we only exist because Jupiter first helped to create the Earth and has protected us ever since. Jupiter is kind of like our big brother. It could be that the same thing is happening in the TY10 solar system. A young star has been formed, and as has been confirmed, 2 gigantic gas planets exist.
Perhaps the gravity of these gas giants, which are probably even more massive than Jupiter and Saturn, so-called superjupiters, is actually transporting material into the inner stellar system, leading to the formation of a twin brother or twin sister of Earth. It could be, because if you look at this solar system, it really is like a copy of our own solar system in its early days, and maybe something very similar is happening there, the formation of Earth-like planets on the inside and gas giants on the outside.
It could even be that Earth-like planets have already formed in this twin system of our solar system, but they are very, very difficult to detect because seeing a planet in another star system is always made more difficult by the light of the star, which outshines the planets. The reason why the two large gas exoplanets could be seen is that they have a gigantic surface area and therefore reflect a lot of light from their star. In any case, I find it super fascinating that solar systems seem to form in the same way everywhere in the universe as they do here. Because if the same processes are taking place just 300 light years away from us, that is, a protostar forms, an exo-Jupiter is created, and this exo-Jupiter swirls matter back and forth, then we must assume that this happens everywhere in the universe. Perhaps the formation of our solar system was nothing special, who knows?
I hope you now have a better understanding of what Earth-like worlds are hidden out there in the universe. Of course, I'll keep you updated here on the channel about all further spectacular discoveries in the search for a second Earth. So if you haven't already, make sure to hit the subscribe button now.
And now let's travel back to our own planet, because there are incredible mysteries to be unraveled here too. Scientists have made a very exciting discovery beneath the Sahara. The truth about the mysterious reach structure, the legendary Eye of the Sahara, has finally been revealed. To find out everything about this groundbreaking discovery, be sure to click on the video in the top right-hand corner. It's very exciting. As always, you'll find another exciting video at the bottom right. Otherwise, I'd say see you in the next video. Take care, everyone.